Alright, let us look at another question from the chapter Areas Related to Circles. Find the area of the shaded region in the figure given below, and pi is equal to 3.14. So first let us try to capture the main idea in this question. So if you look at the figure, this entire portion is being referred to as the shaded portion. There is this outer square which is 14 by 14 centimeters, and there is this inner figure which needs to be subtracted from this outer square. Now if you look at this inner figure closely, it comprises of an inner square and four semicircular portions. But notice that these dimensions are not mentioned, so we'll have to figure out the dimensions based on what has been given in the question. So in order to calculate the shaded area, we would say area of outer square minus area of inner figure. So we see the shaded area is equal to the area of the outer square, which is 14 times 14. That will give us the area of this square minus the area of the inner figure. Next, let us try to understand what is the geometry of the inner figure. So what I've done is I have enlarged this inner figure and I have written some dimensions on it in terms of x. So if you notice, this outer dimension is 14 centimeters and there is a 3 centimeter offset on either sides of the figure. So if you subtract 14 minus 6, you're going to get 8, which means the outer to outer dimension is 8 centimeters in this direction. Same way, if you look at this outer dimension, that's 14, and there's a 3 offset on top and a 3 offset at bottom. So 14 minus 6 again gives you 8 centimeters. So again, this top to bottom dimension is 8 centimeters. That's exactly what I've written here. There is an 8 here and there's an 8 here. Notice that we do not know the dimensions of each of these semicircular regions. The first thing we have to do is assume that all the four semicircular regions are congruent to each other, which means their radius is the same. So let us assume the radius of these semicircular regions is x. So all of these dimensions become x. Now in order to find out the dimensions of the inner square in terms of x, what we must recognize is this vertical dimension is the diameter of this semicircular portion. And since we have taken the radius as x, the diameter becomes 2x. Therefore, this is 2x. Similarly, in order to find out this dimension, we must recognize that this dimension is the diameter of this semicircular portion, in which case this dimension also becomes 2x. So therefore, we have four semicircular portions with radius x each and a central square with 2x times 2x dimensions. But we know that this total top to bottom distance is 8 centimeters. So if I'm going to add x plus 2x plus x, I can equate it to 8 and then pull out the value of x, which I'm going to do now. So I'm going to write x plus 2x plus x is equal to 8, which means 4x is equal to 8 implies x is equal to 2 centimeters. So that tells me that each of this semicircle has a radius of 2 centimeters and the inner square is 4 by 4. So I'm going to right away calculate the area of this inner figure. Area is equal to inner square plus 4 semicircles. So the inner square becomes 4 times 4 plus 4 into the area of each semicircular region is pi r square by 2. So we write pi and r we know is 2. So 2 square upon 2. So I can cancel this and this becomes 16 plus 2 square is 4 times 2 is 8. 8 times pi. Notice we have been told to take pi as 3.14. So this becomes 16 plus 8 times 3.14 and that gives us 41.12 square centimeters. Now all we need to do is, based on what we have written here, the shaded area is equal to the area of the outer square minus the area of the inner figure, which we have just now calculated to be 41.12 square centimeters. Therefore, shaded area is equal to 14 times 14 minus 41.12 and that gives us 196 minus 41.12, which comes to 154.88 square centimeters, which is the final answer.